talking about what a black hole actually is, despite what my mom thinks it's not my bedroom. A black hole is actually a place where gravity is so dense that nothing, not even light, can escape from it. A black hole is so compact that it has an escape velocity greater than the speed of light. The boundary of the region from which no escape is possible is called the event horizon. Although crossing the event horizon has an enormous effect on the fate of the object crossing it, it appears to have no locally detectable features. If you ever enter a black hole past the event horizon, you'll leave the observable universe and are gone. Forever. Forever. Forever.
There are different parts of a black hole. There's the quiet region, which is outside of the black hole and lacks gravitational influence, meaning the gravitational pull is weak and you can pass the black hole without being sucked in. Then you get to the event horizon, where the gravitational pull is greater and the escape velocity is greater than the speed of light, and it's also known as the point of no return. As you go through the black hole, the gravitational space-time is distorted, and the point of singularity is believed to be infinitely tiny, dense point where all matter of the black hole resides.
Black holes are classified by their mass and size. Outside the black hole, the event horizon is a sphere with a well-defined radius called the Schwarzschild radius. The Schwarzschild radius tells us the size of the black hole, but it is dependent on the mass of the black hole. Black holes are classified into 4 separate groups, the first being a supermassive black hole, the next an intermediate black hole, the next a stellar massive black hole, and then finally the micro black hole.
Spaghettification, also called the noodle effect, is the result of vertical stretching and horizontal compression on the object or objects entering a black hole. The extreme stretching is caused by strong tidal forces, which increase to infinity as the object gets closer to the black hole. The outcome of spaghettification is that the object is stretched into a thin strip of matter. Close to singularity, the tidal forces even tear apart molecules.
A good example of what a black hole does not look like or act like can be seen in this Star Trek clip.
USS Kelvin, go for Starfleet Base.
Starfleet Base, we sent you a transmission. Did you receive?
Kelvin, have you double-checked those readings?
Our gravitational sensors are going crazy here. You should see this. It looks like a lightning storm.
What you've sent us doesn't seem possible.
Yes, ma'am, I understand. That's why we sent it.
Report. Still out of visual range. Give me 20 seconds.
Alert Captain Roval and Starfleet advised caution.
Polarize the view screen.
Whatever this is, Klingon origin.
Captain, we have visual.
Repeat, could this be Klingon?
Negative, Lieutenant. You're 75,000 kilometers.
Captain, are you seeing this?
Oh my god.
The first thing that was portrayed incorrectly in this video was the lack of an accretion disk and a Schwarzschild radius for the black hole. Second, like what was stated before, nothing can escape the event horizon. This clip shows a ship leaving a black hole, which is physically impossible. Third, the movie treats the black hole like a wormhole in which they traveled through time, which is also false because as far as we know, a black hole isn't like a tunnel. It stops at the point of singularity. Finally, the simple fact that something came out of the black hole in one piece is also false because spaghettification would have ripped the ship apart.
We'll be counting stars.